Hello to everyone, and thanks to be here. I am Mr. Ruggeri, and I am the technical manager of the Bossong company. In this today webinar, we will try to address the topic of concrete anchors with particular reference to the existing guideline and European and US level. So the following presentation and the scope to give an overview on the European and US method for qualification and design for anchors fastenings in concrete. We will go through the topic according to the following steps. So, how the post-installed anchors works in concrete, design principle of anchors in concrete, European and US qualification and design, seismic qualification in Europe and US, European and US certification, status of the situation, and conclusion. So, how the anchors work in concrete? To understand how the anchors work in this type of base material, you can see this slide. So it's quite easy, and the main principle way of working are for bonding, friction, and mechanical interlocking. So just to give you a simple overview, you can find each type of mechanism correlated to the type of product that you can find in the market. So bonding means that bond adhesion is created between the rod and the base material. So basically you have a chemical anchor with a threaded rod or a rebar. Mechanism by friction is typically used by sleeve anchor or through bolt anchor. So the expansion of the cone creates friction between the cone itself and the concrete surface. And the other type of mechanism is the mechanical interlocking. So the particular geometry of the steel element assure and guarantee an interlocking between the concrete and the thread. The other really important step is the design principle of anchors in concrete. So within the world of the fixing are well known two types of theories behind of the anchors in concrete, that depending on the type of installation. So the first theory is like the standard fixing theory according to the concrete capacity design, CCD. The other one is the reinforced concrete theory. In the first one, so the main application is relative to the fixing of a steel element like a metal plate, for example, to a concrete substrate. In the second one, so the reinforced concrete theory, the target is to connect a new reinforced concrete element to another existing reinforced concrete element. And for this type of purpose, typically only bonded anchor are used. So European and US system today represent the maximum knowledge on the behavior of post-installed anchors in concrete. You can see in this slide the two different systems. So the European system under the OTA system and the USA system under the ACI. Okay, but it's really important to define at the beginning that they are based on common design principle for both, for the concrete capacity design and also for the reinforced concrete theory. You can see an overview about the European design principle. So in the concrete capacity design, the capacity, the tensile capacity of the concrete is directly used in order to transfer the load inside of the concrete. In the reinforced concrete theory, so the anchor is designed as lap splice. This picture comes from the European guideline and the European design document. As you can see, so the same picture and the same principle are used for the USA system. So in the concrete capacity design, the tensile capacity of the concrete is directly used. You probably know the base principle of the concrete cone failure. And then for reinforced concrete theory, the rebar, the post-installed rebar are designed as splice anchor. Regarding the qualification, in Europe, the qualification of anchor in concrete is under the ETAG system. So the ETAG is the European Organization for Technical Assessment. This organization, thanks also to the participation on the industry in Europe, realize the guideline EAD. EAD means European Assessment Document, and inside of this guideline, the producer in Europe can find all the rules to follow in order to qualify an anchor, mechanical anchor or bonded anchor in concrete. So there are a lot of EAD. You can find it inside of the IOTA website if you want, but the real important EAD today are following, as you can see. So the EAD 330499 is regarding static and seismic qualification for bonded anchors. The 330087 static and fire qualification for post-installed rebar connection. Another one for post-installed rebar connection relative to the seismic qualification is the 331522. And for mechanical anchors, we have the 330232. And also we have the EOTA Technical Report 049 regarding the seismic qualification for mechanical anchors. A brief note that EAD now are the reference document for the qualification in Europe for the anchor in concrete, and they have taken the place of the former ETAG that probably more of you know. Okay, but today the reference document are EAD. In US, the qualification is under the ACI, the American Concrete Institute. The ECCEAS is the Internal Code Council Evaluation Service, which review and certify product, components, method, and material to assure they meet requirements of the guideline. The guideline to follow in order to obtain the certification for anchors in US are the ACI 355 and the ACI 308. Sorry. So the first one is relative to the static and seismic qualification of post-installed mechanical anchors in concrete, the ACI 355-2. For bonded anchor, for adhesive anchor, the guideline is the 355-411. And ACI 308 is the acceptance criteria for post-installed adhesive anchor in concrete element for PIR, so post-installed rebar connection. I hope that this slide is useful for you. It's just a summary table to the main document relating to the European and US system. If you want to go in deep in this document, you can find it on the website, and you can find the certification of the product, and also you can find some document and research regarding the design standard that in Europe is the Eurocode Part 2.4 and also the European Technical Report 055, and the US, the system regarding the design is the ACI 318. About the certification in Europe, we have the ETA, so the European Technical Assessment. In US, the product certification is the ECCES evaluation report. So both documents include the technical performance relative to an anchor product. So inside you can find the data about the producer, the product name, description of the product, the application, the intended use, the essential characteristic, the performance. So is the document used by the designer and by the subcontractor in order to understand the level of performance of the product. An important topic regarding the European and US system is the seismic qualification. Today is a very discussed and important topic, and on the web you can find a lot of research, dissertation, and opinion. Let me say some brief note about it. So in the USA system in 2001, the CI 355 document include just at the beginning the seismic qualification for post-installed anchors in concrete, and then they review this type of document in the next year. And today they have only one test protocol. Instead, in Europe, the seismic qualification was introduced only in 2013. So the first document was the ETAG Annex E. Then the ETAG Annex E has been renamed in the IOTA TR 049. And now the IOTA TR 049 will take place inside the specific EAD for bonded and mechanical anchors. And today in Europe, about seismic, we have two test protocols. Test protocol C1, let me say less severe, mainly relative to the non-structural application, and the new protocol C2 that is more stringent and dedicated to structural connection. Basically, the C1 test protocol fully incorporate what is proposed in ACI 355 standard. So you have at least 10 tests for each diameter, 5 tests in traction and tensile, and 5 tests in shear. And the test was performed with a fixed rate of the crack inside of the concrete equal to 0.5 millimeters. So this type of protocol is exactly the same of the protocol used in the USA. So the guideline in Europe is based on the same protocol of US system. So the C1 is exactly the same, but after a lot of study and a lot of the research in Europe, we have decided to insert a more stringent protocol C2. As you can see, instead of 10, you have at least 30 tests per diameter, and the tests are performed in cracks with a dimension of maximum 0.8 millimeters. So this type of protocol is really more demanding on anchor, and the C2 protocol add extra safety for extreme seismic event, and it's used generally for buildings with high importance. So in the world today, for fastening of concrete, some countries prefer use European system, some other prefer to use the US system, but however, both systems represent the highest state of the art on this subject. In fact, this important organization, EOTA and ACI ECC, express their will to collaborate in order to align all the technical specification and to allow the free use of both certification around the world. In this slide, you can see some news and article that comes from the website of the OTA and ECC website. Okay, you can find also the link here. As you can see, the OTA rules are used worldwide, but of course, in some country, the designer prefer to use the USA system. Okay, so there are a lot of discussion around the world about the two systems. So this is the article of the ECCES. Okay, so at the end, in conclusion, it is clear that both protocol, both system in terms of test and assessment are based on the same principle. And so the European system and US system are really similar. Of course, there are some difference, but the two organizations are working in order to align the situation. The seismic design is quite the same, but the difference that the protocol, okay, the protocol C1 is really the same, but the protocol C2 in Europe is really different and is more severe and add more extra safety. As proof of this similarity between the two certifications, in the last year, the OTA organization and also the ECC post article in which they are explained the similarity between the two certifications. And as I told you before, the most important organization expressed their will to collaborate in order to align all the technical specification and to allow the free use of both certification around the world. With this slide, we have ended the webinar. Thanks for your attention, and if you want to know more about our company Bossong, please visit our website bossong.com. Thanks again for your attention. Bye bye.